This video is on quadratics. So to start off with, we're going to look at the graph of a quadratic and some really important points, terminology that you will need. So first of all, the first one here, parabola. Parabola is the shape of the quadratic, so that U shape is called a parabola. It is also possible to have two x-intercepts with a quadratic. It is also possible to have 1 or 0. We can have the y-intercept, so where it crosses the y-axis. We have the axis of symmetry, so that is this dotted line, and that is the line that goes directly down the middle of the parabola. It is symmetrical, is the parabola. And axis of symmetry, we can often be asked for the equation, and that is the x-coordinate of the minimum point, or the maximum, depending which way around the parabola is. In this one here, we have a minimum. It is also possible to have a maximum, so we could have a quadratic that goes this way around, which means there would be a maximum. And the vertex is that minimum or maximum point, the x and y coordinates that make up the vertex, the minimum, the maximum. Now for a quadratic, there are multiple different forms that you may come across. So the first one here, we have the form of y equals a multiplied by x minus p multiplied by x minus q. Now in this situation, p and q are real numbers, so they can't be anything else, but they can be anything. They can be a fraction, a decimal, a whole number. With this form, the p and q are the values of the x-intercepts. Now you will notice in this form, it is minus p and minus q. That the general form has a minus there. So if we put in, if that is x minus 2, and x plus 3, what we find here is the x-intercepts are at 2 and at negative 3, because we have to put negative 3 into that bracket to make it plus 3, and we only have to put a positive 2 in there to keep that negative there, because the general form has the negative already in place. Now in this form, our x-intercepts, as I said, are p and q. Axis of symmetry, so the equation of the axis of symmetry we can find by doing p plus q divided by 2, because it's halfway between those 2 points, so we need to find the middle of those 2 points. And the vertex has the x-coordinate, the same as the axis of symmetry, but often with a vertex we may also be asked for the y-coordinate too. Now really important, with the axis of symmetry, you will more than likely be asked for the equation of the axis of symmetry, which means that your answer must be written x equals and then whatever the value is of that point. Next form is this one here. So we have y equals a bracket x minus h all squared, and we have two of this form. We also have it where we have a k on the end. Without the k, what that means is our graph, our parabola, is touching the x-axis at the minimum or the maximum, depending which way around it is. The axis of symmetry is at that x-coordinate where it's touching the x-axis, and it has a vertex of h0. Now if we add a k on the end, what that does is that will actually move our graph up or down vertically. It's called a translation. We'll talk about that later on in this topic. It is a translation of k. So in this situation, our axis of symmetry is still the h value. Once again, note that it is minus h in the brackets. And the y-coordinate of the vertex is the k value that we add on to the end. So the vertex is at hk, so we can get that vertex straight from the equation itself if it's in this form. Our other form is this one here, y equals ax squared plus bx plus c. Now a few things here. A cannot be 0, and this information is relevant for all the different forms. A cannot be 0, that's for all of them. If a is 0, it's no longer a quadratic, therefore a can't be 0. In this form, c is the y-intercept, only in this form though. So c is our y-intercept. If our a value is greater than 0, then the graph is a happy face. It is concave up. So like all these ones we've been seeing here in the examples above, the a is positive, greater than 0, it makes like a happy face. If a is less than 0, so if that a value is negative, then it is concave down. We'll be making a sad face parabola. If our a value is between -1 and 1, so say a half or a third, the graph will end up being wider than just the general form of y equals x squared. If our a is less than -1 or greater than 1, so anything that's not a fraction smaller than 1, the graph will end up being narrower than y equals x squared. And our axis of symmetry is found using the equation from this form, x equals negative b over 2a. So if we have it in this form of a quadratic, we can find our axis of symmetry with that formula, which is in your formula booklet. Let's just do some examples. So first we'll match each equation to the corresponding graph. So we have 3 equations and 3 graphs, and we just want to find out which one is which. So let's start with A. We have y equals negative 3x squared plus 4x plus 2. Now, things to be mindful of here. The first thing that I notice is it is a negative a value. It is negative 3x squared. Because the a is negative, it means we have to have a sad face parabola, which means it can only be either graph 1 or graph 2. So we've narrowed it down. Next thing to look at is our c value, so the value at the end, the plus 2, which means our y-intercept is at positive 2, because that in this form, that value is our y-intercept. It has a positive 2. Now, in the first graph, our y-intercept is negative. In the second graph, our y-intercept is positive, which means this graph here must be linked to graph 2. Second equation, b, so we've got y equals 2x squared plus 3x minus 4. Now, it is a positive a value of 2, which means it's a hyperface parabola, so straight away we can tell that that would be graph 3. And now obviously that just leaves us with c being graph 1. But what can help us tell that that is correct is, first of all, we have a negative a value. We've got negative 1x squared, so it's a concave down or a sad face parabola. And our y-intercept is at negative 3. And in graph 1, the y-intercept is negative. Therefore, graph 1 must be linked to equation C. Example 2. Sketch the graph of y equals 2x squared minus 16x plus 30. Label any axis intercepts. Okay, first things here, what we need to find them, because we have to label any axis intercepts, we need to find them. Luckily in this form, we have a c value, which means our y-intercept is really easily found by just looking at the c value, which means it will be at 0, 30. Our x-intercepts, we need to solve this quadratic to be able to find those. We need to change the form into brackets. So if we have y equals 2x squared minus 16x plus 30. You need to solve this quadratic however you see fit, whether it's quadratic formula, completing the square, factorising. You've got to work out which method works best for you. This one though can be factorised. First of all, I'm going to factor out this 2 at the front because that's going to make things easier. I'm going to end up with x squared minus 8x plus 15. And then I can factorise that middle bit there. 2 numbers that multiply to get to 15 to add that get to negative 8 is really easily x minus 3 and x minus 5. In doing that, I have it in the formula and know what my x-intercepts are. We've got 3 and 5. So our x-intercepts then will be at 3, 0, 5, 0. It is a positive a value out the front, which means it is going to be a happy face parabola, and then we have enough information to be able to sketch. So if we just draw up some axes, doesn't have to be perfect. It said sketch in the question, which means it doesn't need to be perfect, it just needs to be a sketch. We know our y-intercept has to be at 30, and then our x-intercepts at 3 and 5, and draw the best parabola we can with the information we've been given. But we've drawn the graph, it's the correct way around, it's a happy face because it's a positive a, our y-intercept at 30 and our x-intercept at 3 and 5, which we have labelled. Example 3, find the equation of the graph below in the form y equals ax squared plus bx plus c. Now to start off with here, I've got to look at what information have I been given, and therefore which form is going to be best to put in. So I have been given my x-intercepts. For me then, that means my easy starting point would be to use this form because my x-intercepts can go straight into here. So I'll have x, it's minus 2 there, which means it'd be minus, so we'll have minus 2, and then we'll have x minus 4, and then that will simplify down to just x plus 2 and x minus 4. Now with this, I don't know what a is yet, and we will need that value. But I have been given another point, which is my y-intercept at 0, 8. It's a coordinate, which means I can sub that into this equation to be able to figure out what a is. So the y is 8, a we don't know, but x is 0 at that point. So in the brackets we'll have 0 plus 2, and then 0 minus 4. And we can figure this out. 2 times negative 4 will be negative 8a, and then therefore a would equal negative 1. Now I have that bit of information, we can sub that into the equation and we'll end up with y equals negative x plus 2 and x minus 4. Now in the question we've been asked to put it in the form y equals ax squared plus bx plus c, so now I just need to expand my brackets here. And in doing that, I will end up with negative of x squared minus 2x minus 8. Multiply that negative into the bracket and we'll get negative x squared plus 2x plus 8. And there we have our equation. Example 4, express the function x squared minus 10x plus 7 in the form x minus h all squared plus k, and then find the coordinates of the vertex. Now to put it into the vertex form, we actually need to complete the square. So we have to draw on our knowledge of completing the square and use that to solve this. Now when we complete the square, the b value, which is the value attached to the x, remember we need to halve that and then square it, and then we do an add and subtract of that to the whole equation. So if we have x squared minus 10x plus 7, just rewrite it in a form that's going to work for us. So we'll have x squared minus 10x, but that b value of negative 10 divided by 2 and squared will just end up being negative 5 squared. So we're going to put that into here, and then we're going to plus 7. Now because we added this negative 5 all squared to the equation, we also have to minus it. So we're not changing the actual equation, because plus negative 5 all squared minus negative 5 all squared will equal 0, and we end up with our original equation. But by doing it this way, we just put it into a form so we can complete the square. Now in doing it this way, we've now got this bit here, which ends up being a perfect square. So we can rewrite that straight away as x minus 5 all squared. So that b value halved ends up being the value that goes into the brackets, and then that part's sorted. And then we have to do the plus 7 minus 5 all squared, which means we'll have plus 7 minus 25. And then if we simplify all that together, we'll end up with x minus 5 all squared minus 18. So this just requires us to remember how to complete the square. Once we do that, we are all good to go. So that is part A. We're putting it in that form. Now for part B, coordinates of the vertex. Now we've got it in this form. Vertex is really easy. It's just the values that we have for h and k, which means our vertex will be at 5, negative 18. Now once again, remember, the general form of this equation is negative, so it is a positive 5. Next example, express the function 3x squared plus 9x plus 4 in the form of, once again, ax minus h squared plus k, and then find the equation of the axis of symmetry. Now with this one, we have a value in front of the x squared. Therefore, to complete the square, the first thing that we have to do is factor that out. So we'll factor this out here. So we'll have 3x squared plus 3x plus 4 on 3 to factor that out. Now we need to complete the square with the middle part. So our b value here is positive 3. So we need to half that and square it. And now we're going to add and subtract the equation to make it into the form that we like. So we keep the 3 at the front. We'll have x squared plus 3x stays the same. Then we're going to add in our b value halved and squared the value there that we have at the side, which would be 3 over 2 squared. Then we're going to continue with our equation. So the plus 4 and 3 we have a question. Then because we've added this in, we also need to minus it away, so we are not changing our equation. Once we've done that, we can do our next step, which is taking the first part of this equation. I'm just putting the box around there and put that into another set of brackets. So we'll have x, we take our value in the blue in the brackets, which is 3 over 2, and that's positive, so it'd be x plus 3 over 2 all squared, because that is now a perfect square. And then plus 4/3 minus 3 on 2 all squared. When we put all that together, let's do that by hand, because you could be asked to do it by hand in an exam. So we'll have 4 on 3 minus 3 on 2 all squared will be 9 on 4. And then we have to be able to add those two fractions together. You will get an answer of minus 11 on 12. Then we just need to multiply that 3 back into the bracket, so we'll end up with 3 x plus 3 on 2 all squared, and then 3 times 11 on 12 will just give us minus 11 on 4. So those little things with fractions, you need to be able to do that without a calculator, so make sure you're just practicing your fractions knowledge. Part B here then, find the equation of the axis of symmetry. So the axis of symmetry is the x value of the middle of the graph. Now when we have an equation in this form, remember this is h and k, so the axis of symmetry is our h value. Now because it is a positive in there, it means on the graph it is at a negative, so x would equal negative 3 on 2, so just that h value. Now it says the equation of the axis of symmetry, which means you have to write x equals negative 3 on 2. You can't just write negative 3 on 2, you will be marked incorrect. Example 6, find the equation of the following parabolas. We're not told in which form, so we'll just go through and give these a go. So the first one, we have the two x-intercepts, which means we can go straight to the form just like we did in the previous examples. Now remember, because the x-intercept is at negative 1, in the bracket it will be at positive 1, and then the positive 3 in the bracket will be at negative 3. Then we need to work out our a value. We have a y-intercept at 3, which is when x is 0, which will give us a negative 3a, so a will equal negative 1, and then we can put that into the equation, so we'll end up with y equals negative x plus 1, x minus 3. So depending on what information depends on the form. Part B, this time we have a minimum or a vertex, which is at 2, 0. So because of that, we can put it in the vertex form, which is our a bracket x minus h all squared plus k. We don't know a just yet, but we do know h, which is the x value of our vertex, which is at 2, and k is the y-coordinate of the vertex, it's 0, so we don't need to put that on there. Once again, though, we need to find the a, and we have another y-intercept at 8, 0, so we can sub that in. So 8 equals a, 0 minus 2 all squared, which makes us have 8 equals, minus 2 squared is 4, 4a, so 2 equals a. Sub that back into the equation, and we'll have y equals 2, x minus 2 all squared. Part C here, we've got to look at what information we have got. So here we have an x-intercept. We also have an axis of symmetry at x equals 1. There's not one form right now that works with that information, but because we know the axis of symmetry is at x equals 1, that is directly in the middle of the graph, which means we can actually work out the other x-intercept because it is exactly halfway between both. So if this first one is at negative 2, the distance between negative 2 and 1 is of 3, which means the distance from the axis of symmetry to the other x-intercept is also 3, which means that will end up being at 4. So we have two x coordinates there then, and we can go to our intercept form. So we'll end up with y equals a, x plus 2, and x minus 4 in our brackets. We have a y-intercept again of 16, 0, so 16 equals a, 0 plus 2, and 0 minus 4. Which means we end up with 16 equals negative 8a, and so a equals negative 2, and then we can sub that back into the equation, and we'll have y equals negative 2 multiplied by x plus 2 multiplied by x minus 4. Part D, we have a vertex here. That's the information we've been given at 3, negative 2. So we can go straight to our vertex form of a bracket x minus h. The h is 3 there, so it'll be x minus 3 all squared, and our k value is minus 2, so that just goes on the end. We then need to work out the a value. We have a y-intercept at 16, which means we'll have 16 equals a. The x is 0, and we can work this out from there. So we'll have 16 equals negative 3 squared is 9, so it'll be 9a minus 2. 18 equals 9a, just rearrange this, and we end up with a equals 2. Then from there, sub that into the equation, and we'll have y equals 2, x minus 3 all squared minus 2. And that is the end of this video on quadratics.